Hello students, good morning. Today I am going to discuss idea of sets. In this chapter we already completed 3 sessions. So this is the 4th session of the chapter idea of sets. In the previous class we discussed some exercise question. In first session and second session we learned about the definition of set and what kind of the statements will form the sets, right? So set is nothing but it's a collection of the well-defined objects. Set is a collection of the well-defined and distinct objects, and these sets are represented by the capital alphabetical letters, whereas the sum of the objects which are existing in one particular set, that objects are called as the elements or members of this set, right? So usually the sets are represented by the capital alphabetical letters from A to Z, whereas the elements or members of the set is representing with the small alphabetical letters from A to Z. Okay, and we discussed the one more important concept, that is the representation of the sets with the help of the 2 methods. The first one is roster method or tabular form, and the second method is roll method or set builder form. Roster method means, in that method we are writing all the elements inside the braces, inside the curly brackets. That curly bracket we call it as a braces. So we write all the elements inside the braces by giving some spaces or by inserting some commas also, right? In roll method or in set builder method we write the particular statement or condition or formula or law that should be satisfied the existing element of the roster method or tabular forms. In this session I am going to discuss the one more concept, that is the type of these sets, types of the sets. The first one is finite set. See the word finite. Finite means the word itself defined as it has some countable numbers, right? Finite means the set has finite elements. So how you can define the finite set? A set has finite number of elements, or a set has the countable number of elements, then that set is called as a finite set. For example, if I am taking the statement as the English alphabetical letters, a set A has English alphabetical letters. Set A has English alphabetic letters. So you have definite number of the English alphabetical letters. So how many alphabets are there in English? There are 26. So this 26, it is countable, no? All that existing alphabets are countable. So these type of the sets are called as a finite set. We'll take one more example here. A collection of set B is a collection of the single digit prime numbers 2, 3, 5, 7. So these are the only 4 prime numbers which are in single digit. So if I say the word, what are the single digit prime number means? How many single digit prime numbers are there means? You can easily identify there are 4 single digit prime numbers. They are 2, 3, 5 and 7. So these are the single digit prime numbers. How many single digit prime numbers are there? 4. This 4 indicates the set B has finite number of elements. Here also the 26. This 26 indicates that the set A has the finite number of elements. It means it is a countable set. Clear? So finite set means what? A set, any set has the countable number of elements or members, then that kind of the sets are called as a finite set. It's a purely countable set. It is purely countable set. Okay? Here I will take one more example. C is a set of first 100 whole numbers. first 100 whole numbers. If I say the word first 100 whole number means what you have to write? The usually whole numbers are start from 0, 0, 1, 2 and 99. 99 is the 100th whole number. If I take 100 means the total number of whole numbers are 101 because we are including 0 here. Once I start from 1 means 1 to 100 is 100, right? So here I am already taken 0 because 0 is a one of the whole number. It means the total 100 whole numbers, the first 100 whole numbers are from 0 to 99. How many whole numbers are there here? 100 whole numbers. So this 100 indicates that the set C is a finite set. Clear? So what is that example of finite set? A set has finite number of, or a set has countable number of elements or members, then that type of the set is called as a finite set. Okay. Next one, in finite set we will count the number of the elements existing in that set. Okay. Next one, second type is infinite set. Infinite set. Infinite set. Infinite set. First one is finite set and second one is infinite set. Finite set means it has definite number of the elements or members in the particular given set. But in second one, infinite set, see the word infinite, it is completely reverse to the converse of the first one, opposite of the first one. It means the finite set has definite number of elements or members in the set, but infinite set has uncountable number of the elements or members in the particular given set. So these two are the common differences between the finite set and infinite set. So finite set is a countable set and infinite set is a uncountable set. Can I take the examples for infinite set? If I take A as a set of the natural numbers, set of the natural numbers, set of the natural numbers. So usually the natural numbers are start from 1, 2, 3, 4, 5, 6 like that. We can write infinite number of natural numbers, infinite number of infinity. The number of the elements or members existing in set A is infinity. This is the infinity symbol. This symbol indicates it has infinite number. It means we are not able to count the number of elements, number of members which are existing in set A. Take one more example. The collection of whole numbers. Collection of whole numbers. Usually natural numbers are start from 1, 2, 3 and so on. Whereas the whole numbers are start from 0, 1, 2, 3 and so on. Right? Again, these whole numbers also uncountable. We cannot count these whole numbers because we have infinite number of the whole numbers. 0, 1, 2, 3. What is that next one? 4, 5, 6. If I am writing or considering the next numbers, it is purely uncountable. We cannot count the number of the elements which are existing in set B. So set B is a infinite set. Set B is a infinite set. See the next example, the collection of integers. Collection of integers. Okay students, you already know about the integers. Integers are the numbers which are having both positive values and negative values along with the 0. It means -4. We have here few more negative values like -5, -6, -7, -8, -9, -10 like this. So these dotted points, I already told you in the previous classes that dotted points will indicate the series is in the continuous form. -3, -2, -1, 0, 1, 2, 3 and so on. So can we count these numbers which are existing in set C? No, because it is a purely uncountable set. Uncountable set because it has infinite number of elements in set C. Can I give one more example? The number of the stars which are existing in the universe. We cannot count how many stars is existing in the universe. So that is also one of the example for infinite set. Okay. Okay, so clear? The first one is finite set and second one is infinite set. Finite set means the set which has the countable number of the elements or members, whereas this infinite set means the set which has uncountable number of. It means it is not easy to count the number of elements or members which are existing in that particular set. Okay. Next, see the third one, that is empty set. Empty set. So empty set means what? The name itself says empty means what? There will be nothing. So empty set means if a set has no elements, if set does not have any element, then that type of the sets are called as a empty sets. So it is a do not have any element. Means if I am taking here A as a set and this set, empty set is called as a one more name is null set. Null set, or we have one more name for the empty set, that is void set. Void set. So these two are the names referring for the empty set, and empty set is represented with a symbol of empty brasses or like this. These two symbols we are using to represent the empty set. So empty set means what? If a set has no elements, then that type of the sets are called as a empty set. For example, A is an empty set. Like this also, A is an empty set. It means the set A does not have any elements. Set B is an empty set. These empty brasses indicates that the set B do not have any elements, right? So this is the third type of the sets, that is empty set. Empty sets usually do not have any values. Next one, cardinal number. Cardinal number. So this is one of the important concept, cardinal number. What do you mean by the cardinal number? Here I am taking example. Through this example, I will clear that what is the exact meaning of the cardinal number. If I am taking set A as 1, 2, 3 and 4. So what are the elements of set A here? 1, 2, 3, 4. How many elements are there in set A? 4 elements, right? So this number 4 indicates the cardinal number. How many elements are there in set A? 4 numbers, no? There are 4 elements which are existing in set A. This 4, the number of the elements which are existing in one particular set, is called as a cardinal number. Cardinal number. So how you can define the cardinal number? Cardinal number is the number, it indicates that the number of the existing elements or members in the particular set, and it is denoted by the symbol n of set. N of set. It means in the place of set we write it as n of A. N of A. N of A means cardinal number of set A. N of A means cardinal number of set A. It means it indicates the number of the elements which are existing in set A. For example, here set A has 4 elements and it is denoted by the symbol n of A is equal to 4. If I write n of A is equal to 4 means this 4 indicates the set A has 4 elements inside the brasses. Okay. Next one, set B, A, E, I, O, U. What is the cardinal number of set B here? Set B cardinal number is, how many elements are there in set B? 1, 2, 3, 4, 5. 5 elements are there, no? So cardinal number of set B is 5. Cardinal number of set B is 5. Okay. Next, take one more example. C is the set of the English alphabetical letters. English alphabetical letters. So how many English alphabetical letters are there means the cardinal number of set C is 26, because the totally 26 letters are there in English alphabets. If I take The vowels of the English alphabet means what is that cardinal value? There are total letters existing in English alphabet letters are 26. In that 5 vowels are means the remaining letters are 21. So 21 is the cardinal number for the set of the English consonants, English consonant letters. Okay. Next one. Here the one more important concept is if a set has only one element, means if a set has set P has one element only, that is 1. If set P has one element means these type of the sets are called as a singleton set. So singleton set means any set, if any set has only one element or only one member, then that type of the set is called as a singleton set. For example, Z is a set of, here Z is a set which is having only one element, that is A. Okay. Next one. If set has 2 element means Q is a set of 1 and 2. Q has here 2 elements, that is 1 and 2, or M has a set of N and P. These 2 are the elements which are existing in set Q and M. 2 elements are there in set Q and 2 elements are there in set M. So these type of the sets are called as a pair set. Pair set. So how you can define the pair set? If any set has 2 elements, then that set is called as a pair set. Okay. If a set has single or one element means that set is called as a singleton set. If a set has 2 elements, then that set is called as a pair set. Okay. Next one, some important concepts related to the cardinal numbers. First one, every finite set has the fixed cardinal number. Every finite set has the fixed cardinal number. It means what? We already know that finite set means we can count the number of elements which are existing in the particular given set, right? We already discussed this one, first one, finite set. So finite set means what? The set which has the definite number of the elements or members in the particular set. We can count the number of the elements existing in that particular set, means we can easily write the number of the elements existing in the finite set. For example, if I am taking A as a set of 2, 3, 5, 7, 8, 9. So this is the one of the example for finite set. So what is the cardinal number of finite set? 1, 2, 3, 4, 5, 6. So how many elements are there in set A? 6 elements. Therefore, the cardinal number of set A is 6 here, right? So for every finite set, we can write the cardinal number. Second one, when we are writing the cardinal numbers, we need to write that all elements in the tabular form or in the roasted form. Why? Because in sometimes when we are writing the elements inside the process, we neglect the repeated elements. For example, if I am taking the word, set A is the word, letters of the word Karnataka. Letters of the word Karnataka. So what is the cardinal number of set A here? How many elements are, how many letters are there in the word Karnataka? 1, 2, 3, 4, 5, 6, 7, 8, 9. So cardinal number of set A is 9, means it's completely wrong. Why? Because whenever we are going to be represent, already discussed in the previous sessions, in the rule method and roster method, these type questions we already solved, no? So how we can write this set A? By just neglecting the repeated letters. Here K repeats 2 times. It means we need to write it as 1 time only here. Next, A repeats 1, 2, 3, 4 times. A repeats here 4 times. We need to write it as 1 time only. Next, R, N, T. R will not repeat again here. N is also not non-repeated letter. T is also non-repeated letter. Okay, now this is the exact finite set. So now cardinal number of set A is, count the number of the elements which are existing in set A. 1 2 3 4 5. Here you are getting the exact meaning of the cardinal number. Just observe these two. What we write in the first one, the cardinal number of set A is 9, but the exact cardinal number of set A is 5, because that set has some repeated letters. Okay, so it means whenever you are going to be write the cardinal numbers of a particular set, you need to be write that first in the roster method or in the tabular form. If some elements or some members repeated, means that repeated elements neglect and write it one time only. The repeated values we write once only and write the cardinal number according to that set. Okay, this is a second important property that is related to cardinal numbers. Next, third one is for infinite sets. Infinite set means what? The number of the elements which are existing in one particular set, we cannot count that elements. It means that set has uncountable number of the elements. So for infinite set, we cannot write the, for infinite set we cannot write cardinal numbers. We cannot write cardinal numbers because the cardinal number of infinite set is infinity. Infinity means it is highly impossible to count the number of the elements which are existing in that infinite set. Okay, so the third property is for infinite set we cannot write the cardinal numbers because it has infinite number of elements or infinite number of members in the particular set. Now fourth one, every empty set, if n is or set A is a empty set, means for empty set or null set or void set, the cardinal number is always 0. The cardinal number is always 0. That means the every empty set, the cardinal number is 0, means the empty set do not have any elements, right? What is the definition of empty set? Do not have any element. The set which do not have any element, that type of the sets are called as a empty set. If a set do not have any elements or any members, then how we can write the number of the elements which are existing in that particular set? So we cannot write, no? We cannot write it, means the cardinal number of set, empty set is 0. So these are the four important properties related to the cardinal number. The first one is we write the definite number of the cardinal numbers for finite set. Second one is when we are writing the cardinal numbers, we need to write or we need to represent that set in the roster method or tabular method before we are writing the cardinal numbers. If some elements or members is repeated, means just neglect that repeated values and take it as a one time only, then write the cardinal numbers according to the set. And third one is for infinite set we cannot write any cardinal numbers. For infinite set we cannot write any cardinal numbers because that set has infinite number of the elements. If they ask what is the value of, what is the cardinal number of infinite set, means that is infinity, right? So we cannot count the number of the elements which are existing in infinite set. And last one, fourth one is for every empty set the cardinal number becomes 0 because the empty set do not have any element. If set do not have any element, means we cannot write any cardinal numbers. Okay, next one, fifth one, equivalent set. Equivalent set. Equivalent set. So equivalent set means what? If two sets having equal number of elements, then that two sets are called as a equivalent set. For example, I am taking here set A as 1 2 3 4. set B as A, B, C and D. Now what are the elements of set A here? 1, 2, 3, 4, and the elements of set B is A, B, C and D. How many elements? What is that cardinal number of set A? The cardinal number of set A is 4, and the cardinal number of set B is also how many number of elements which are existing in set B? 1, 2, 3, 4. So set A and set B are having equal number of elements. So these two sets are called as the equivalent set, and these equivalent sets are represented with the symbol N is equivalent to N of B. Set A is equivalent to set B. Here you can take any letters. Set M is equivalent to set N, set X is equivalent to set N, set C is equivalent to what we are taking sets, no? So if any two sets having equal number of elements, then that two sets are called as a equivalent set. But the main concept is just in this equivalent set we are concentrating only on the numbers of the elements, numbers of the elements existing in two sets, number of the elements existing in two sets. Okay, next one, the next type is equal set. So equal set means what? There is a slight difference between equivalent and equal set. This is an equivalent set, no? The first one is, this is equivalent set. Equivalent set. Now I am taking the example for equal set. Equal set. So what is the meaning of equal set? Again, here I am taking the two sets. If two sets are having equal number of elements and all the elements which are existing in set A and as well as in set B are same, means here I am taking set P. The elements of set P is 1, 2, 3, 4. Set Q. The elements of this set Q is 1, 2, 3, 4. Just observe the elements which are existing in set P and Q. What are the elements existing in set P? 1, 2, 3, 4. These four elements existing in set Q also. It means one belongs to P and Q. One belongs to set P, it belongs to set Q also. 2 belongs to set P as well as it belongs to set Q also. And 3 and 4, these are elements which belongs to the same set P as well as the set Q. And count the number of elements which are existing in these two sets. The set P has element, how many elements are there here? 4 elements. Whereas the set Q also has the elements 4. If any two sets are having equal number of elements along with the same elements, then that type of the sets are called as a equal set. That type of the sets are called as a equal set, and these equal sets are represented by the symbol A is equal to B. It means the set 1 is equal to set 2R, set M is equal to set N, set P is equal to set Q. Here set P is equal to set Q. It means the cardinal number of set P which is equal to the cardinal number of set Q. So this is the main difference. Just observe the differences between equal set and equivalent set. In equivalent set we are concentrating only on the number of the elements which are existing in two sets. If two sets having equal number of elements, then that two sets are called as a equivalent set. We are concentrating only the number of the elements which are existing in two sets. In set A and set B, these two sets are having 4 elements only. Okay, so if two sets are having equal number of elements, then that two sets are called as a equivalent set. Whereas in equal set, the number of elements in any two sets, the number of elements as well as the existing elements should be same. The existing elements should be same. It means here we are considering the number of elements, and elements should be same. Elements should be same. So this is the main difference between equivalent set and equal set. In equivalent set, the number of elements should be same. The number of elements, it means the cardinal numbers should be same. Then we call it as a we call it as a equivalent set. If two sets are having equal number of elements, along with that the two sets are having equal elements, then that two sets are called as a equal sets. Okay, so these are the some basic types of the sets. In the next class we will discuss subset, superset. Okay, until then, be happy, have a nice day. Thank you for watching video.